In this next example, we are told that there are 2 points on the same latitude, and the latitude is 56 degrees north. 56 degrees north. 56 degrees north. So this is the latitude. This is the center of the latitude. And we are given the points. Let me locate the point. One of them is 23 degrees east. 23 degrees east. So let's assume this is our 23 degrees east. And the other one is 17 degrees west. 17 degrees west. So let's just label them A and B. The question is, find the distance measured along the parallel of latitude. So I'm looking for the distance measured along parallel of latitude. They are both on the latitude and measuring along latitude. So this is the distance I'm actually looking for. This is the distance, and it's along latitude. So this is the distance. Because it's along latitude, I will trace to the center of the latitude. Latitude is a small circle. I'll use small r. I'll use small r. And remember, recall, small r is equal to capital R cos the given latitude. Capital R cos the given latitude. I want to do something here. I want us to do something. Let's say 2 pi r. I want us to use 40,000 kilometers for 2 pi r, wherever we see it in the formula, to make our work easier. So let's write the formula. Now, because they are both along the same latitude, we also need this. We need this. I want to use alpha here to represent the angular difference. Like we have been doing before, the alpha will be this 23 degrees plus 17 degrees, and that will be 40 degrees. Why am I adding? By now you should know they are on different sides of the pole. I'll add to get my 40 degrees. So the next thing is I want to get the distance along the same parallel of latitude, and the formula is alpha over 360 2 pi small r, and small r is capital R cos given latitude. So that will now be written as my alpha is 40, which is over 360, then times, I said let's use 40,000 here, so this is 40,000, then cos my latitude, which happens to be 56 degrees. I will take that again for clarity. The angular difference, we all know how to do it. This is a formula that you need to remember. It's the same formula as theta over 360 2 pi r, which is the length of an arc, because this is actually an arc. Go back to that previous video and watch. It will do you a lot good. So, and small r is equal to capital R cos beta, where beta is the given latitude. All I needed to do was just to substitute. And after you substitute, whatever you get becomes your answer. In this case, I will take my answer to be 2490 kilometers. And that is it. Please do not forget that you can pause the video and go over till you master it. In this question, we have to find this pile of latitude located in the northern hemisphere. And there's a journey between 2 points on this latitude that is 640 kilometers if you look at the question properly, and that journey makes an angle of 8 degrees. So let's just locate any 2 points and put an angle there for you to see. let's assume that I have an angle here, sorry, a longitude there, and I have another longitude here. So somebody journey from here to this place, and this is the center of the latitude. So if I draw this to form the radius, and I draw the radius again, second part of the radius, and there's an angle here which I've been calling alpha. So they are saying here that the alpha is now 8 degrees. This is the distance we are talking about, and they have given us that the distance is 640 kilometers. And this distance is along the latitude. So we use the formula for distance along latitude. This is already the angular difference. So the formula is alpha over 360 2 pi small r, which is capital R, cos given latitude. So by the time we substitute all of this unknown, this will be the only unknown that will be left. So in this question also, I want us to use 40,000 for this to make our workings faster. So we're going to have 8. Sorry, let me start with the distance, make it easier. We're going to have 640, which is equal to 8 over 360 times 40,000, then cos beta. You can see that is now the only unknown. So you just cross multiply and you will see that your cos beta will be equal to 640 times 360, which will be over 8 times 40,000. Cos beta will now be equal to 0.72, and beta will be equal to cos inverse of 0.72, and the cos inverse of 0.72 is 43.95 degrees, which we can approximate to 44 degrees to the nearest whole number. It's as simple as that. All you need to do is understand what the question is saying. Distance is along the pile of latitude. Use the formula for pile of latitude. Substitute everything you have. Then the only unknown you have is what they are looking for in this case, and that solves the problem. In this question, we are told that there is a particular point X on a latitude that is towards the north. So the point X is on a latitude 32 degrees north. So let's say this is the diameter of the latitude, 32 degrees north. And there's a point here, they call that point X. And we are told that calculate the speed. See that? Calculate the speed of X due to the rotation of the Earth. Calculate the speed of X due to the rotation of the Earth. And we know that the Earth rotates, makes one complete revolution in 24 hours. You know, it goes like that in 24 hours in that direction, 24 hours. So that means, since they have said due to the rotation of the Earth, they want us to calculate the distance from here now till when it came back to this point. That's the meaning of that statement, due to the rotation of the Earth. So, and you know that if the point starts from here and ends here, the angular difference, is on a latitude now, and I'm using alpha. So the angular difference there will be 360 degrees. That's what the angular difference is going to be. And by the time I plug this into the formula, you will discover that that part where we have alpha over 360 will be gone. That part will be gone. So because it's on the latitude, I'll simply calculate the distance. That will be d equals alpha over 360 2 pi r cos beta. Don't forget that, cos beta. So this is now 360 and this will be gone. So I can write this formula as 2 pi r cos beta. Now slotting in everything that we have and still using 40,000 for this to ease our calculation. We're going to have the distance here to be 40,000 times cos 32 degrees. And D will finally give us 40,000 times 32 degrees is 0.8480 kilometer. We multiply this, whatever you get will be the distance. But they're asking us to find the speed. The question says calculate the speed. And we know that speed is equal to distance over time. So all I need to do is substitute those values and that will be all. So I have 40,000 times 0.8480 over the time. Due to the rotation of the Earth, it goes for 24 hours. So the time here is 24. So this is kilometer, this is hour. So that my answer will be in kilometer per hour. So in the end, I'm going to have 1410 kilometer per hour. It's as simple as that. So whenever the question says due to the rotation of the Earth, you can as well remove this part because it will be 360 divided by 360, which will be 1, so it will be gone. So your formula will remain 2 pi r, small r because it's on the latitude, small r, which is now capital R cos alpha. I keep emphasizing that because if the point was here, we're going to use 2 pi capital R and there won't be any cos beta. That's it. So please take notes and do not forget this very important formula for speed. Please do not forget that formula. Yeah.
If you enjoyed our teaching, please click like and feel free to share our link with your friends, and do not forget to subscribe to our channel so that you can get notifications of our subsequent videos.